Students. In today's class, we are going to talk about the rules for naming aliphatic cyclic compounds. Naming of aliphatic cyclic compounds. And you know that the aliphatic cyclic compounds are also known as alicyclic compounds. So in the naming, what are all the rules to be followed? You can find one by one what are all the important rules that have to be noted and they have to be considered. Here, it's a very simple idea. By knowing this, you can build your own self-confidence while facing so many number of conversions and the reactions in the organic chemistry. The first rule, the case one. Suppose if you are given a structure like this, it shows that there are 4 carbon atoms. So it is easy to write its name as cyclobutane that everybody knows. Simply to the root word, 4 carbons are there. Word is butane. And in the prefix we are adding cyclo. So it becomes cyclobutane. Normally this is the other one. We can call it as cyclohexane. So many number of examples can be given. And this can be given as follows. And you can have a compound like this. Suppose there is a double bond in between these two. It is to be called as cyclohexene. And there is a instance, a cyclic compound given like this. It can be called as cyclopentane. And if it is the case, there are 8 bases. So we can call it a cyclooctane. The first idea is very simple. Based on the number of carbon atom in the ring structure, you can find a root word. And to that root word, in their prefix, you give the word cyclo. The rule was very simple to recall right. Now the case 2, we'll try to consider. Suppose in the ring structure, if there is a side chain, otherwise if there is a substituent, otherwise if there is an alkyl group in the ring, then how to give the name? It's a best example. We can take, this is called a cyclobutane, as there are 4 carbon atoms in the ring structure. Suppose in one of the corner, when you find CH3, this can be called as methyl cyclobutane. Likewise, name butane, 4 carbons. If you find C2Hi, then it can be called as ethyl cyclobutane. Easy to write the name. And if it is the case, if you are given a substance like this, When there are 6 carbon atoms in the ring structure and there is branch found in this position, you can call it as methyl cyclohexane, as there are 6 carbon atoms in the linear chain. And likewise, if you find a ring structure in which there is a functional group called OH, cyclohexane, in which the last letter E is to be replaced by OH. So it becomes cyclohexanol, an aliphatic ring type alcohol, cyclohexanol. The ring structure, it may have some branches like this, otherwise substitutions. The substitution means either it may be a alkyl group or a functional group. Then it is easy to give its name. Suppose more than one substitution is made. If more than one substituent of same variety or same type or present means, the naming can be done as follows. You consider a cyclohexane in which there are 2 substitutions like this. So I can give the numbers like this: 1, 2. 1, 2 dimethyl cyclohexane. That's IUPAC for the given aliphatic structure. When the substituents are not same, if they are not same, they are not belonging to the same category, then what to do? Yes, we are given a substance like this. One is methyl and other one is ethyl. And we must give preference to this ethyl. That should be counted as number 1. This is number 2, 3, 4, 5, 6. So the compound's name is given as follows: 1 ethyl, 2 methyl cyclohexane. That's IUPAC name of this compound. When the alkyl groups are same, the number can be given in any order. But the alkyl groups aren't. You should prefer the highest alkyl group having more number of carbon atoms. And alphabetic order shows that ethyl should come first. And due to that, we are writing it as 1 ethyl, 2 methyl cyclohexane. Okay. And if it is the case, the next one I am writing and you know that it's a pentane, particularly cyclopentane. You see now 2 branches are found. One is ethyl branch and other will be the methyl branch. Yes. Now you just take it as number 1 ethyl, 2, 3, 4, 5. So its name must be 1 ethyl, 2 methyl cyclopentane. So ethyl is written and followed by methyl. You just see the priority. Ethyl should be given preference. And if it is the case, you see a cyclohexane in which the substitutions are present as follows: CH3, CH3, and other position is having C2H5. Then your numbering should start from this case: 1, 2, 3, 4, 5, 6. There are 6 carbon in the lineage. So it must be cyclohexane without any doubt. And ethyl is present in the first position, so it must be 1 ethyl. There are 2 methyl groups available. They are present at carbon number 2 and carbon number 3. And hence it is 2,3 dimethyl cyclohexane. 1 ethyl 2,3 dimethyl cyclohexane is the name. The other group, if same is bonded with 2 methyl groups and other carbon of ring is attached with ethyl, and the rule slightly differs. Just see the difference. And we have to take an example as follows. We consider the following cyclic compound in which it slightly differs. I can write a ring structure, the cyclohexane, in which the same carbon atom is connected with 2 methyl groups. Okay. And other carbon atom is attached with ethyl. In the previous example, 2 methyl groups are present in 2 different places, but here the methyl groups are attached with the same carbon. If it is the case, when more than one substitution is merged in the same carbon atom, that carbon should be preferred, and you have to take that as number 1. Here, don't prefer this ethyl. It must be taken as 2, 3, 4, 5, 6. So the root word, as usually, hexane, cyclohexane. And regarding the branches, ethyl is present in cyc position. The first position can have 2 methyl groups. Right name of the compound must be 2-ethyl 1,1-dimethyl cyclohexane. This is the name of the compound. In the same way, if you try for the following, just see one other cyclic structure having 5 carbon atoms in it. Yes, cyclopentane. Here you can have 2 methyl groups. In this position, 1 ethyl is present. Then what will you do? Yes, you can call it as cyclopentane without, and it should be preferred. This is number 2. Second position can have ethyl, 2-ethyl 1,1-dimethyl cyclopentane. That must be the name of the compound, cyclic compound. Okay. Apart from this, when there is a presence of both, the other rule, the ring has got unsaturation, which means a double bond. And a substituent, then which is to be given preference? You consider this particular substance, you know it is a cyclohexane. If there is a double bond, you can call it a cyclohexene. Now I can attach two branches here. One is methyl, other one is ethyl. Then how do you give the name of this compound? Here the unsaturated must be given preference. Okay. You can take like this: 1, 2, 3, 4, 5, 6. Okay. In the opposite way, you cannot count. Suppose are trying like this: CH3, C2H5. The wrong way of counting. You cannot count like this. As you consider, this is number 1, this is number 2, number 3, number 4, number 5, number 6. It cannot be counted like this. Okay. The unsaturation should be given preference. So this is the wrong way of assigning the number, and this is the correct way. And here we can write the cyclic compound in which cyclo, totally 6 carbon, we are writing it as 6. Unsaturation is at first position, 1 in. Now the methyl group is present at second position, 2 methyl. And ethyl group is present at the 5th position, so it must be called 5 ethyl. This should be the right name. Let's compare this name with the other one. It's a wrong name. You see, this is also X 1A, but unfortunately the same is having methyl, 1 methyl, and 4 ethyl. So a name cannot be like this. It's a wrong name. X 1A, 1 methyl, 4 ethyl. Try to understand. While giving the numbering, unsaturation is given preference. Okay. And this is the correct name: 5 ethyl, 2 methyl, cyclo X 1A. By this you can understand. And one other rule when writing the IUPAC name. So most important rule, the next. It's very, very important and essential thing. Suppose if the ring is bonded with an alkyl group, if that alkyl group is having more number of carbon atoms than the ring, then ring should be, the ring structure should be treated as a branch. Very important. When the ring can be treated as a branch, when the alkyl group is having more number of carbon atoms than the ring structure. I'll give a case so that you can understand. It's the best example. C3, CH, and that is a ring structure having 3 carbon, H2, CH3. See, there are 4 carbon atoms present in the linear chain, but the ring structure is having only 3. 3 is lesser than the top 4. The parental substance should be taken as butane. We should treat this as a derivative of butane. So I can write the root word as but. As it is a saturated substance, you can call it as butane. Now, the second question in which you are finding a branch, what's the name of that branch? It is said to be the cyclopropyl branch. That's the compound's name is 2-cyclopropyl butane. So it's easy. 2-cyclopropyl butane. Okay. And I'll give one more example. CH3, CH2, CH, CH2, CH3. In this position, suppose if you find a branch like this, see the number of carbon atoms in a linear chain. How many carbons are there? 5. But the ring is having only 4 carbon atoms. So the derivative of pentane, the compound is pentane, in which 3 cyclobutyl group is present. So the compound's name must be 3-cyclobutyl pentane. Okay. In contrast with this, opposite to this, and alkyl group is having more number of carbon, then that is treated as a parental compound. In opposite to that, suppose if alkyl group is having lesser number of carbon atom than the ring structure, now ring must be taken as the ring is considered as parent alkane, and the alkyl must be treated as a branch. Okay, we can have a verification. It's a simple example. If the alkyl group is having less number of carbon atoms, it might be the best example, CH3, CH, CH3. And you are finding a butyl group in this position. See the number of carbon atom in a ring structure in a linear chain 3. But the ring has got 4 carbons in it, so that you can call it as butane, in particular cyclobutane. The second position is having propyl. You can call it as 2-propyl cyclobutane. That should be the name of the compound. 2-propyl cyclobutane is the name of the compound. And we can have other example. Let me give the example. Consider this case: CH3, CH, CH2, CH2, CH3. If there are 6 carbon atoms in a linear chain, you can call it as hexane. And a branch is found in the second position. You see 1, 2, 3, 4, 5. Now it is to be called as 2-cyclopentyl hexane. In opposite to that, CH3, CH2, CH3. If you find a ring structure like this, it differs. You see the number of carbon atoms in a linear chain, that is 5. But the ring is having more number of carbon atoms. How many carbons are there? 6. So it's to be called as cyclohexane. And the second position is having a branch. The name of the branch is pentyl. Thus it is 2-pentyl cyclohexane. I think you have followed. So whenever the ring is having more number of carbon than the alkyl group, the ring is treated as a parental alkane. When the alkyl group is having more number of carbon, then alkyl is treated as parental hydrocarbon and a ring is treated as a branch. So that's also an important rule. And apart from that, you can have one other important rule. You consider the following rule. If both unsaturation and halogen or other groups are present in the ring, then the preference should be given to unsaturation. Very, very important. You should give preference to the unsaturation. Consider this case. And we will be having an example for this category. A cyclic compound. Here it is a double. Here I am writing the BR. And what is it? You just count from this side. 1, 2, 3, 4. So that you can call it cyclo. First is having the unsaturation, cyclobute 1A. And the presence of bromo at third position. So that we can call it as 3-bromo cyclobute 1A. Consider the other one. If it is the case, having the double bond here, and there is a presence of Cl. Now the rule says that 1, 2, 3. So it must be called as cyclohex 1ene. The chloro is present at which position? Third position. So it is to be called as 3-chloro-cyclohex 1ene. Is it clear? Likewise, in the other case, you can find a functional group. is we will be having the functional group in the side chain, the other row. If side chain is containing functional group, side chain is having functional group, then the cyclic structure is treated as branch. It must be treated as a branch. Here, you need not worry about the number of carbon in the ring. Whatever may be the number of carbon atom in the ring structure, that you need not consider, because the side chain is going to have a functional group. So the side chain must be treated as a parental source. I'll give an example for that case. You see, there is a cyclic compound. Now in this position you are finding a branch. That branch is nothing but CH3, CH2, C double bond OH. It's an aldehyde. The functional group is there. Then this is a way to count. We are giving reference to the functional group. Totally 3 compounds are there in the linear chain, so that you can call it as propane, as it is having the aldehyde function. It will be ended with AL, propanol. Now the branch is found at second position. The name of the branch is cyclobutyl. This is the branch, cyclobutyl, which is found at second position. Cyclobutyl propanol. And number of carbon atom in the ring structure need not be considered, and you do not card that with the side chain, because the side chain is having functional group, and giving preference to that functional group. We can have one other structure as follows. This is the structure. Consider it has got CH, double bond O, CH3 in one side. In the opposite side, we can have CH2, CH3. Count and find the number of carbon atom in the longest linear chain. It's a way to count 1, 2, 3, 4, 5 carbons. So it must be called as pentane, as this ketonic function at the second position. It called as pentane 2-one, 2-pentanol. Now the branch is found at third position. This line, which is highlighted or highlighted. The name of the branch is hexyl, cyclohexyl. So thus it is 3-cyclohexyl pentane 2-one. That's the compound's name. It has got a functional group C double bond. So many number of examples can be for this case. Yes, I am writing one other structural formula. If it is the case, we can have CH3, CH, CH2, CH2, OH, 1, 2, 3, 4. So it is to be called as butane. 1, isn't it? Butane 1. The branch is this one. This is the branch. Which is present at third position. It is to be called as 3-cyclohexyl butane 1R. It's an alcohol. So it's also a very simple rule. Now, an aliphatic ring structure, the other rule, has got multiple double bonds. Okay. And those double bonds are present both in the side chain as well as functional group. Then the ring is again treated as a branch. I'll give an example for this particular case. If side chain and ring both are containing double bonds. Okay, double bond. Preference can be given to side chain, and ring is treated as a branch. Very important. Yes, you take a simple example. It's a ring structure. Here there is a presence of CH3 CHC double bond OH. And the preference should be given to the functional group. 3 carbons are there. So it must be called as propane. Yeah, without any doubt. Okay, propane. Yeah. And this is the first position of the ring. This is second position, third position, and then fourth position. Definitely cyclo butane, but in which the second is having the unsaturation. 2A, 1Y. I repeat, cyclobute 2A, 1I. This is present in which position? In position number 2. I repeat it. You consider this compound, the same compound I am repeating, CH3, CH, C double bond OH. Here there is the presence of the ring structure. This is the ring what we are finding. See the number of carbon atom in the lineage chain, 3. So you can call it as propane, propanol. Okay. The branch is found at second position. What's the name of the branch? This is the branch. The branch is having 4 carbons, so you can call it a cyclobute. Unsaturation is present at position number 2, so 2-ene. This cyclobute, first carbon is getting attached with the propanol. So 1-yle. 2-cyclobute, 2-ene, 1-yle propanol. This is indicating the position of unsaturation. The 1 is in the attachment of cyclobutene to the propanol. The first carbon is getting, and hence it is 1-yle. This 2 is indicating the position of cyclobutyl. It is present at the second position of this propanol. And in this way, you can analyze and understand. And we are giving the other example. It's another example. Consider this compound. There is a presence of CH2, CH, CH3, CH2, C double bond O, which is a carboxylic acid. Here there is a double bond. How you give the numbering? This is the way by which you can give the numbers 1, 2, 3, 4. So the source compound must be butane. You can compute it as it is the carboxylic acid. It can be called as butanoic acid, OIC acid. The branch is found at third position, so that you can write as 3-methyl butanoic acid. 3-methyl butanoic acid. And you should find out the ring is the branch. This is the ring. Where the ring is attached, it is present at the 4th position. What's the name of that ring? Cyclo. As it is having 5 carbon atoms in it. The carbon 1, 2, 3, 4, 5. So we can call it cyclo pent. In the cyclopent, the double bond is present at the 3rd position. So 3-ene, 1-yle. 3-ene indicates that the 3rd position of the cyclopentane is having unsaturation. 1-yle is indicating the first carbon is getting attached with this. This 4 out of the bracket is telling the position of the cyclopentane 3-ene, 1-yle to the methyl butanoic acid. In this way, the compound's name can be explained. Okay. And other simple rule. Based on this, if the ring as well as side chain contains the functional group, both of them are having functional group. In the previous case, the functional group is present only in the side chain. Now both side chain as well as the ring, both of them are having the functional group. So which is to be given preference? That's the next rule. The functional group what is present in the side chain may be given preference. Based on that, the next rule can be explained. Yes, we can have an explanation as follows. Just a second, it is buffering. So far we were seeing so many number of rules from the beginning. Presence of side chain, when there are more number of alkyl groups, how to assign the name. When there is a presence of unsaturation in the ring structure, then how to assign the name, and how to compare the chain length of side chain and the ring structure, and how to put the correct name. All those things we were seeing so far. Okay, the next. Yes, now you see the other one here. The other row we can highlight. If both ring and side chain have functional group, both of them are having functional group, then functional group can be given preference. The functional group present in side chain can be given preference. Yes, you see, in a cyclopentene in which of CH double bond CH single bond COOH, and one more functional group is present at NO2 in the ring structure. 1, 2, 3, 4, 5. This is one way by which count. And other one, CH double bond CH COOH. Yeah, it's NO2. Yes. Induced by can count 1, 2, 3, 4, 5. So this is the right way of counting. The nitro should be highest possible prefix 3 rather than counting it as 4. So the naming can be given as follows. Yes, you should find out the number of carbon in the lineage chain. 1, 2, 3. As there are 3 carbon atoms in the lineage chain, you can call it 2-enoic acid. Why? The double bond is present at second position, it's carboxylic acid. Now the ring is the side chain, or the ring is treated as a branch. propanoic acid. The name of the side chain, this ring structure should be considered branch. It is present at which position? Third position of the propanoic acid. So 3 we can write. And in the ring structure, in the position 3, you can find a nitro. 3 nitro. 3 nitro. Cyclopentyl is the constant. I repeat, 3 nitro cyclopentyl prop 2 enoic. This number 3 is indicating the third carbon is connected with ring structure. This 3 is indicating the position of nitro. And 2 is indicating the unsaturation, what is positive chain. Very, very simple. Okay. And both the things, both ring as well as functional groups are present in the ring structure as well as in the side chain. Now, the ring should be treated as a parental source rather than the side chain. Okay. You see the other example. It is the other example. You see this compound in which one of the functional group is OH. The ring is also having OH and the side is also containing functional group like this, CH2, CH, and then CH3. Then the preference should be given not to the side chain, but it should be given to the ring. Matter, both of them functional group, but the preference should be given ring structure, not to the side chain. So how do you assign the name? Count from this side. 1, 2, 3, 4, 5, 6. 6 ones are there in the linear chain. So it can be called as hexane. Hexane 1 all. What kind of hexane is it? It is a cyclohexane. So cyclohexane 1 all. First step is over. Then it should be treated as a attachment. What kind of attachment? That attachment is found at second position. Okay, it is present at the second position, in which totally 3 carbons are present. So I can call it propyl. But the second position of that propyl is having hydroxy group. 1, 2. So you can call it as 2-hydroxy. Propyl cyclohexane 1 all. I repeat, 2-hydroxy propyl cyclohexane 1 all. That's the name. See the thing? The cyclohexane, in which position 1 is having the functional group. 2-hydroxy propyl. It means in the propyl, second carbon is having the functional group. 2-hydroxy propyl. That 2-hydroxy propyl is bonded with the second carbon of the ring structure. So 2-hydroxy propyl cyclohexane 1R. Okay, that's the case. If more than one ring structure is bonded with the source compound, both the ring structures are treated as branches. Okay, and this is the best example. You see the other rule. When there are more than one ring structure, more than one ring structure. Consider this is a ring structure, cyclopropyl group, CH2, CH2 connected with butyl. So this can be given as follows. It is the position 1 according to the size. This is position 2. The ring is having 4 carbon. So the parental source is E. So that we can say the first position in which you are finding cyclobutyl. In the second position, you can find cyclopropyl. Thus, the compound's name is 1 cyclobutyl 2 cyclopropyl ethane. When more than one ring structure, you must give preference to the chain, not to the ring. The rings are treated as branches. Okay. And we can so many number of examples like this. Suppose to the benzene structure, some of the aliphatic rings are getting attached. You must treat that as benzene is treated as main hydrocarbon. You see, it is the benzene structure to that the cyclic compound is attached in this manner. Then treat the benzene as a parental source, benzene. The cyclo is getting attached with that. So what type of cyclo? Cyclopentyl. So that we can call it a cyclopentyl benzene. So these are the few ideas by which you can give the IUPAC name of aliphatic cyclic structure. Various rules so far we were discussed. Okay, I hope this may be a beneficial video for you for understanding the naming system in the case of aliphatic cyclic compound. Thanks for watching. Thank you.